There is third way of avoiding data hazard, which is called the code scheduling. So suppose we have a code, simple code like this: a equals b plus e, c equals b plus f. I'll assume that all these variables are stored in memory at an offset, something called x31. So this thing would be translated into something like this. Okay. So here you can see we are loading b, let's say into x1, and we are loading e, let's say in x2, and then we are performing addition. So here load instruction, what we are loading, we are using it in the next instruction. So there is clearly a data dependency between the load instruction and the next R type instruction. So data dependency here and data dependency here. So what do you think the total program, how many clock cycles will it take? That could be a very good question in exam also. How many total clock cycles will this program take? 9. Why?
On top of like single instruction, you have to install at least 2 NOP.
So it should be taking more cycles then.
7 plus 2.
So how long will the, okay, wait.
45.
No, it's too much. How did you calculate that?
Added 5 each time.
Anyone from the back side?
It's not 9.
Hmm?
It's not 9.
It's not 9.
Is it 11?
You are very close.
13.
Huh?
13.
How? You got it, actually. How you come up with the value 13?
Everybody was just saying 10.
So you were just throwing a stone?
Yeah.
Why not 15?
That's too much. That's too much.
Why not 12?
You already said it was 13.
It is 13. So why? Because first of all, we have 5 stages in pipeline, right? So the first instruction will take 5 clock cycles to complete, right? So the first instruction will take 5 clock cycles to complete. If you look at here, how many clock cycles this instruction is taking? 1, 2, 3, 4, and 5. And then the next instruction is taking 1 additional clock cycle. Okay? So the first instruction is taking 5 clock cycle. This one will take 6 clock cycle. And because, or maybe just go directly like this, 5, 6, 7, 8, 9, 10, 11. But because of this data dependency, we need to have a bubble in between here, which means a stall of 1 clock cycle here and a stall of 1 clock cycle here. So that is why total 13 clock cycles. You get it? No? Want me to repeat?
No, he was asking me something.
Repeat. So first instruction takes 5 clock cycle. The next instruction take the 6th clock. By the 6th clock cycle, the next 2 instructions will be completed, right? For this instruction to execute properly, we need to stall for 1 clock cycle. That is the 7th clock cycle. And then this instruction will take 8 clock cycle to complete, and then 9, and then 10, and then again, because of the data dependency, we have to stall, which is the 11th. This will take 12, and then this will take 13. Okay? So in this type of code, we actually change the placement of the instruction, and instead of putting x4, LWX4 here, we put it here, reading all the contents from the memory altogether. And now there is a gap in between of reading x2. So instead of putting a bubble, we execute another instruction. Okay? So it helps us reduce the number of bubbles or number of stall cycles. So this program will now run in 11 clock cycles. Okay? So you could be given a similar kind of problem, and you should be able to identify how many number of clock cycles are taken by the program. So you see the LW here, there is a data dependency, but there is already an instruction in between, which means that another instruction is already executing. Instead of waiting for the clock cycle, we have actually utilized the same clock cycle to execute another instruction. Get it? Any question? Do you want me to repeat? Nicole, yes? This side? So do you understand this point? Because we have the data dependency right after in the next instruction. And we have already seen that in the previous slide, no matter whether we are forwarding, we have employed the forwarding technique, we still have to pause for one clock cycle if there is a data dependency between the load and the next instruction. Okay? So whenever you see RD here, and this is one of the RS being used here, so we have to pause for one clock cycle in between. Okay? So we change the placement of instructions in this case, and now you see X2 is not immediately used in the next instruction. Rather, it is used in the instruction one after the another instruction. So instead of waiting for one clock cycle, we run execute another instruction in between. So that is why we do not need to install, which we were installing here. Okay, and without actually changing the functionality of the program. Similarly, X4 is written here, but we are not using in the next clock cycle, not even in the further clock cycle. It is used after 2 clock cycles. Okay, so we have avoided the data dependency, or we have avoided the clock stalls by rearranging the codes. Okay. Again, you need to ensure that it does not change the functionality of the entire program.